In today's video, we are looking at one of the simplest yet most important design patterns called sequential prompting. So sequential prompting is a design pattern where you break a task down into a series of different steps and each step's output becomes the input for the next. This helps create a clear linear flow, perfect for applications where reasoning, task execution, or content generation must follow a structured path. Now let's analyze this simple workflow right here. So we begin at the start node where our count is set to 0. From there we move to node 1. This node increments the count to 1. The updated count is then passed to node 2, which increments it to 2. The updated count is then passed to node 3 that receives that updated state and increments it to 3. Finally, we reach the end node with a fully updated state. This entire chain is an example of sequential prompting where each node builds directly onto the result of the previous one. Now let's implement this pattern to get our basics all clear. Alright, for starters, let's build our state graph first. So today we'll be working with Pydantic. In my previous video, we worked with Typedict. So this way you can have the flavor of both these parameters that are accepted by our state graph. So we can say something like from Pydantic import our base model. Then we'll build our graph state. We can call this graph state. Pass in our base model. It will have a count variable which takes in a value of integer. And we can specify a description for the same. So we can say something like field contains a description field, and we can call this the current value of our count. All right, this has to be d with a small d actually. And now we should start building our nodes. So we can say class node underscore 1 takes in our graph state. We get the current count value, and this has to be a function. We have to get the current count value. So while working with Pydantic, we have to use the dot operator. So we can say state dot count. We increment the count with 1, and then we return the updated graph state, right? So that is what we discussed in our workflow as well. So now I can just copy this 2 more times and just change the names. So this becomes my node 2, this becomes my node 3. And now we can start building our graph. So for that, I have to import the starting and end nodes, along with my state graph. So now I can say something like builder equal to my state graph, which takes in my graph state. I have to add my nodes. So this becomes my node 1. I can do this 2 more times and then just change the names. So this becomes node 2. This becomes node 3. Now we define our edges. So we start with our node 1. From there, we go to node 2. So from node 1, we go to node 2. From node 2, we go to our node 3. And then we finally end at our end node, right? So from node 3, we go to our end node. Now I can compile this graph and say graph equal to builder dot compile. And now to see our graph inside the terminal using Grandolph, we can say something like graph dot get underscore graph dot draw ascii. All right, and now we can run this. Before that, let's activate our virtual environment. So we can say .venv slash scripts slash activate.ps1. Clear this, say python main.py, right? And you can see the graph has been printed inside the terminal. Start node, node 1, node 2, node 3, and the end node. Now we'll invoke this graph. So for that, I can just comment this out and say my response is graph.invoke with the starting value of my count variable set to 0. And now if we run this, we'll see the count go from 0 to 3. Yeah, so this is working fine. Now that we understand how sequential prompting really works, let's look at a real world use case, which is a story generation application. This diagram shows a pipeline that begins with a title generator then passes the title to a story generator, and finally refines the result with the story improver. It mirrors the same pattern, that is input to transformation to handoff. The only difference is the complexity of the data being passed. This is where sequential prompting really shines. It gives you control, modularity, and reusability even with creative tasks. Now let's improve our previous code to follow this workflow. For starters, let's invoke our LLM first. For that, let's add our environment variable. So we can say from .env import load underscore .env, and we can call that function at the root of our Python script with override equal to true, and then we can specify our LLM. So for that, I can say from langchain underscore proc import chat proc, and then I can instantiate that in my LLM. So I can say chat grok with a model name and a temperature value. So we'll set it at 0.8. So we'll be working with Meta's Llama 4. And now we'll have to make changes to our graph. So let's just delete or comment this out right now. And we have to define our nodes and edges again. So we can remove this. And we have to actually remove all of this as of now. So in a graph state, we'll have a title. So before that, we need to get the user's input first. So we can say it is a string with a field of description equal to user input. Let's call this user input. Then we get a title, which is also a string. And we can say its description is the title of the story. And we have the story itself, which is also a string. And we can say its description is again the story of, no, let's just call this the story. And finally, we have our improved underscore story, again a string, and we can specify that its description would be the improved version of our story. All right. So now there is one error. Do we have to specify commas? No. I messed up it. It's supposed to be this operator, not the equal to sign. So now let's build our nodes. So for that, let's specify our first node called title underscore generator, which takes in a graph state. And then we fetch the user's input first. So we say user underscore input equal to our state dot user underscore input. And now we have to invoke our LLM with a prompt. So now we have to work with prompt templates. So if you want to know more about these prompt templates or something like that, just go to the description and you'll find the link to their documentation there. So you can refer to them. So I can say my prompt equal to prompt template, and I can specify my template is generate a title for the following story, for the following input actually, and I can say respond with only the title, and it has some input variables as we can see. So these prompt templates actually help us to make our inputs dynamic for the LLM. So this is one of the benefits while working with LangChain and LangGraph. So I can now specify a chain. So we first get our prompt, then we invoke our LLM. So now I can have my response by invoking this chain with my user underscore input set as my user input from the state or from the state graph, right? So now we return the updated state, that is our title, to be our response dot content, obviously, because we'll be getting an AI message from this. And from our previous video, we know that if we have to fetch only the content from the AI message, we specify that by saying response dot content, right? So now I can just copy this again and build my story generator. So now this becomes my title state dot title generate a story for the following title, respond only with the story. My input variable becomes a title, so I can just say this as title, and again my title is my title, and here we replace this by our story is being returned from this node, right? Again, response.content. Lastly, we have to improve on the story, so I can say something like improve underscore story, right? So now we fetch our story first from the state, and we say improve the following story. Improve the following story, and this becomes our story again. Respond only with the story, that's correct, and our input variable is story with the value of story. And okay, there is a spelling error right here. And lastly, what we get is our improved underscore story as response.content. Again, we have to build our graph, so we define our nodes first. So our first node is our title generator, then our second node is our story generator, and finally we have our story improver. Now we define the edges again, so we say we start at our title generator, from there we go to our story generator, then improve story, and then we finally end at our end node, right? Again, we can see this graph in action by printing that out in the terminal itself. So I can say python main.py and override. Okay, it's override, not override. Let's print this again. Improved underscore story requires a type annotation. Okay, again the same mistake. This has to be this, not an equal to sign. And yeah, as you can see, start, title generator, story generator, improve story, and end, right? So now we invoke our graph with an input. So I can say user underscore input becomes my tell me random story. Print this, comment this out. And before we actually run this, we have to make these all fields optional. So our title story and improve story have to be optional, because while invoking the graph, we are only specifying the user's input, right? We're not giving any context about title story or this. So we have to make these fields optional for the beginning of our graph run. So for that, I can say from typing import optional. So we make these fields optional and then specify the type that we that they take, that is string. And we also specify a default value for these fields, because if we work with Pydantic and we make a field optional, we have to specify their default value as well. So now this should work fine. It's running, the graph is running. Yeah, so now you can see we set our input to be tell me random story. We got a title saying the whispering walls of Winterwood. That's quite a nice title. Then we get a story. There should be our improved story somewhere also right here. So if you can point that out, just tell me in the comments. So yeah, this was all about it for today. That wraps up our look at sequential prompting. All code and documentation referred to in this video are linked below, so be sure to check those out. Thanks for watching, and I'll catch you in the next one.